I'm extremely grateful to you, Professor Rao, for inviting me because uh, it's always a pleasure to go to university and talk to young students. I chose this topic essentially to show that why earth science in last about 15 years or so is getting some importance, as you rightly said that it was not much. So I have picked up a few examples that how this science has helped in different aspects. It's not changing.
You have to point it on.
Yeah, I have to point this side.
Yes.
Okay, this one. Huh?
Yes, sir. To point for going down.
Yeah,
and
yeah.
Before sliding.
Okay.
Yes.
So, what we are trying to do is to understand the various Earth system processes. Now, the most important thing which we know that the Earth is a single unit, and whatever the change or the exchange of mass and energy takes place between different components like atmosphere, ocean, or a hydrosphere, biosphere, geosphere, and snow and ice. Now, you can see that this all energy essentially comes from the sun. And this activity, like as you know about simple example of a monsoon, when ocean hits up, the water evaporates, goes to atmosphere, then it transfers, wind takes it to land, the rainfall comes, again through stream, the water comes back to. So there is several such processes where there is a continuous exchange of mass and energy. Now, in this, the human influence in last 150 years has started interacting with these processes, and in many times it affected those processes. At the same time, these processes also affect our activities. And that is why this subject has become very important, because there is a direct interaction with the society. So, in the broad sense, now why this is very important? The one is it brings many other sciences together, the science as a whole. The other is a space science. Why space science? Because after the satellite started orbiting Earth, we realized that there are many processes which are regional and global, and there is a lot of interconnection between them. So the Earth science, when we say, it is also part of the space science, which is one of the most important. And then, since it is connected with the society, the social science is also equally important. And the benefits which come, so economics and cognition. So it basically integrates different sciences together about the Earth processes, which we need to understand weather, climate, hazards, because this Earth which gives us an ecosystem to survive. So basically what it means that it provides an understanding and the physical basis of the Earth in which we live, and we need to sustain this process. Now, how this started? Initially, it of course started with the geoscience. Somebody can say that I have little bias, but the global level processes we tried to understand was how the mountains evolved or how the oceans evolved. The next came the biology. The biology as a major geological force was recognized in 19th and 20th century, and which actually allows the diversity of life because of its interaction with the geosphere. We know now that the life exists even the 6,000 meter below on the ocean. We drilled a well in, I will come back to that, Karad, 3 kilometers, and there also we found that the virus and microbes are present even at that depth. So there is a lot of such things which is happening, which may not have fully understood, but now we know now that the biology and geological science has a very close interaction. And this anyway, I told you that in 60s, we learned to measure and observe various processes. We derived many parameters, and with the advance in computing, we also started assimilating this in numerical weather models. And then we started giving forecast about variety of things. And that how it started impacting the society. The last 150 years, we know that the human impact has been substantial, and we are seeing many changes which are occurring, and the changes in the hazard pattern, the heat waves, the monsoon pattern, several things. So that is why it is very essential that we integrate our knowledge about physics, biology, chemistry all together to understand this global change and how we can mitigate and adapt to these changes. Now, there are basic 4 features of the Earth system, of the Earth system processes. The one is there is a large variability across space and time, and many times what happened in the past, especially the paleoclimate study, which is a very important aspect of geoscience, that what happened in the past, maybe 10,000 years ago, some studies hundreds of million years ago, or since beginning of the origin of the Earth. So this past behavior of the Earth is very important for us to understand what is likely to happen in the future. As I told you, the biologic processes are extremely important, and this is one which is very important component of the Earth system science. While most of the time they felt earlier that what has to do biology and geoscience, but now things have drastically changed. Other is these processes are connected in variety of ways, both laterally and vertically. You can see the global regional processes. So this is which was not known. So there is a lot of connection. I will show you 1 or 2 examples of this. And the most important is that this system is strong non-linearity. That means even a small change can bring a large abrupt change into the system. That is why currently what the scientists have consistently derived that 1.5 degree or at the most 2 degree is something, a threshold we should not cross, because once you cross, there could be a catastrophe. And this is essentially because these processes are not linear. We exactly don't know if you cross that, what is likely to happen. Now I will give you a few examples. One is the hazard is one of the most important challenge of this century. We have seen that the kind of damage to property, losing of lives is tremendous, not only in India but throughout the globe. Now, how this was improved upon? If you see the cyclone, if you take an example, some 20 years back or 25 years back in 99, in Orissa, we lost more than 10,000 people. Today, if you see the last cyclone which came to Gujarat, it was reported that there is no life lost. Now, how it was possible? The one thing which was very important which happened is in 80s when we started launching the INSAT satellites, which provided the aerial extent and their track, how it is moving. Also, the other satellites provided information about when the ocean started heating up, where it heats up, and what is likely to happen, the winds from the scat. So, variety of satellite data provided the initial information what is situation in the ocean. While the earlier the radars were able to see about 300, 350 kilometers, so the time was not there. But now we know that what is happening. At the same time, lot of other observation platforms in the oceans, Argo floats and AWS and the buoyed buoys, drifting buoy, so many instruments are there. All are being assimilated into the models. And we have been able to achieve about landfall accuracy about 40 kilometers. Now, this is something which is almost at a saturation level because those who know the cyclone I itself may be about 25, 30 kilometers. So, if you can achieve this 40 kilometers is something extremely good. So, we have been able to know what is the accuracy of a landfall, about 40 kilometers, and intensity is almost 85% cases is very accurate. So we both know that where it is going to occur and what is likely a damage. And at the same time, because this forecast has improved, the confidence of the state and the national governments also increased. People also started trusting the forecast. So the lives have been saved now tremendously. So this is the one which is very important. And this advisory we are giving not only to India, but also to all countries in Bay of Bengal and Arabian Sea. It is recognized as a regional specialized center, meteorological center, to provide this services. So this is something extremely good for the India that we have been recognized as a major knowledge provider in this region. Now, of course, there are many others things to be done. The one thing which we are unable to do is the wind profile from the satellites, which is a one challenging task. My colleague from NRSC would know that. So this is another area where we need to work. Also the hyperspectral data which can provide you the thermodynamic structure, the improved resolution of the profile, humidity, temperature profiles. This is goes on. So we would be able to improve. But this is a classic case which is proved that using the science, how it could be benefited to the society. If you count the damage, which is, if you see in Myanmar, some 2.4 billion rupees damages were, so we are being able to save. So this is one very classic case. The second is about tsunami. In 2004, when tsunami came, we were totally unprepared. Most people even don't know what is tsunami is. Even it came, hit first Andaman Nicobar early in the morning, 6 o'clock. We were not knowing that it will come to Chennai or Tamil Nadu and the Kerala coast as well. So Government of India decided to set up a warning system, and this is a very, I would say, very complex system because you need the earthquake data in a real time. It has to be processed in a real time because it takes about 2.5 hours for if earthquake occurs in Andaman Nicobar or Indonesian arc to reach India. And Andaman Nicobar, it takes only 30 minutes. So the time with which you have to do is a very short, about 10 minutes. And in this, you need to process the all earthquake data, the sea level changes data, and you have to find out whether it is tsunamigenic or not. So what we did is, we used a very novel approach, is generated a simulations for all possible earthquakes in this region. That means there are about 50,000 different scenarios. So we generated those scenarios for each particular earthquake in a grid which is 100 by 50 kilometer. And then this was stored. That time it was the 15 terabyte of data. Today it is a simple thing. but in 2006 and 7 it was a huge data to handle, and then you should be able to pick up the right scenario. And then this has to go to, we were doing a forecast for each forecast point. That means every 50 kilometers, there are 1800 forecast points. The reason for that is that time US and Japan used to give a warning which is basin-wide. That means Bay of Bengal will get a tsunami. You can't do any action with that kind of thing. So we started this coastal forecast points. So there are 1800 forecast is generated when the tsunami is likely to come and what would be its height. And this is all done within 10 minutes without any human intervention. So it's completely automated system, because if it happens at night and the operator is just dozed off, you can't. So this is completely done. And of course, once the first warning goes, then the experts also come in and then they find. So this system has been working for last 15 years without any single false warning. That is the beauty of this system. Now, at the same time, the earthquake is an area which is, we have not much handled to predict. And the one simple reason why we are unable to predict is, this occurs way below in the earth, maybe 10, 15, 30, 40 kilometers below the earth. So we are not able to observe and measure what kind of changes occurs before, during or after the earthquake, which was possible in case of a cyclone or a tsunami when you observe something. Whatever we know about the earthquake is through geophysical measurements, which is indirect way to interpret things. Now, we know that this we are unable to predict. So there are different ways and means we try to understand that where the most probability exists. And currently, of course, there is a not exactly 100% consensus, but most people believe that the next large earthquake may occur in the central seismic layer, that is part of Uttarakhand, Himachal Pradesh. The reason for them is that we know that the kind of a stress which is now building up through GPS, the measurement, we know that only 50% has been released. Another 50% is yet to be released, and we don't know when it would be released. So, since we are unable to know when it is going to happen, what we need to do is, one, we need to have a microzonation maps. That means we need to understand that if earthquake occurs, how the particular local area, soil and all will affect the buildings. Because most people die because of the buildings, not because of the earthquake. Because of the buildings fall and people die. So, this microzonation maps are being prepared, and there is a possibility of an early warning system, because the P waves comes first and then the S waves, which are actually more damaging. So P waves we get in the Delhi, if earthquake occurs in Himalaya, you get about 90 seconds. Now many people think that what you can do in 90 seconds, actually you can run out of this building within 10 seconds. So 90 seconds is a huge time. You can stop metro, you can stop power stations, many such things. But that system is still under experiment, but it will happen sooner or later. Once you know that this area is prone to an earthquake, you need to strengthen the health infrastructure and the public buildings like education buildings, the police station, government buildings, colleges, town halls, where people can be given shelter. So they should be strong enough, and also the residential building, next phase, it has to be done. So this is how the earthquake is being addressed. But there are other kinds of earthquake. I don't know how many you may know, but there are many places, especially those who are reading newspaper near Bombay, near Palghar, in Saurashtra, and many other places. There are small earthquakes are coming, which may not be very damaging, but people get panicky. And many of these earthquakes are called triggered earthquakes. It is happening because of the anthropogenic activities like large scale mining or a reservoir or we don't do in India much, but the hydrofracking, which is very prominent in US, which also brings a small earthquakes. Now, this kind of a triggered earthquake, the reservoir has the Koina, which occurred in 1967, about 6.7 magnitude earthquake, which was very strong in that sense, and the entire town was flattened, and the lot of damage and loss of lives. About 200 people lost their lives. So, whether we can understand this kind of an earthquakes. Now, this work throughout the globe has been initiated. That whether how do we understand this triggered earthquakes, especially happened because of the reservoir. There are many reservoirs in the world this has happened. Many experiments were tried, but none of them were successful because whenever they tried to do, earthquakes stopped happening in those places. But in India, we have a beautiful site, what is called the lighthouse site, where the earthquakes are still occurring after 50 years. And it is occurring in a very small region, 20 kilometer by 20 kilometer. And this gave us an idea that if we put a deep borehole, we would be able to measure what happens, what kind of physical and chemical changes occurs before, during, and after the earthquake. So this was a major experiment plan, and we drilled a pilot borehole, which is up to 3 kilometers, to find out where we should drill the main borehole. Because you have to go to the area where earthquake is occurring. So you need to locate that fault and then make the measurements. So this has been now drilled completely with the indigenous technology. First time in a hard rock terrain such a deep borehole has been. Now there are, apart from earthquake, there are two very important things came out, that the contact between the basement granite and basalt is sharp. There is no in between any other sedimentary rocks, which was expected most people. The second is first time we know that how the lava flow right from the initiation to the end. So entire sequence is now known. But the important thing which we learned as far as the earthquake is that these rocks are not strong enough, the basement rocks are not strong enough to sustain sufficient strain. So with the little bit increase in the strain, they break. So there is not a possibility of earthquake which could be more than 5.8. Dr. Tiwari and his colleagues have done this work, and this very important conclusion that 5 point cannot happen more than 5.8. That means in this region, if we know that cannot happen more than 5.8, all preparations can be done. Let's say you put some error margin, let's say 6.5. So you can plan all the activity according. So this is one major thing which has come out. But the experiment is still, this is one experiment which I must say that planned for 20 years. Nothing can be done in few years, because to drill this 3 kilometer borehole, there's a lot of preparatory work. Actually, 5 years of preparatory, there was 10 boreholes of 1 kilometer. Then the site of pilot borehole decided this. Now we have put instrumentation in this, and we'll decide that when to drill the 7 kilometers. So another year or two, we will start drilling the 7 kilometer borehole. And then we will be putting instruments in this region where the earthquakes are occurring. So we would be able to measure actual changes, what is happening. And that will tell us many things, that whether we can model the reservoir-induced seismicity or not. This is, of course, the area which is, we don't know what exactly caused it. But what we know is in the Rishiganga, you can see that the large mass of an ice, about 0.34 square kilometer, dropped 3,800 meter. You can imagine the kind of such a rock mass when it drops such a huge 3.8 kilometer, what kind of a havoc it can create. But the interesting thing is that it has developed a fracture earlier. Of course, we learned this later on. And so this kind of fractures which are building up, we don't know exactly why this is happening. So this is an area for the earth scientists to understand that whether we would be in a position to find out this kind of a fractures which are developing. We have the satellites which goes every 5 days, every day, every 3 weeks. So whether we can build some kind of an understanding of developing such kind of a fractures. The floods, of course, is one other major, and the urban floods, I won't go into the details of too much, but the urban floods forecasting is now possible. There is a lot of different models are used, hydrodynamic models because it's on the coast, hydrological model, hydraulic models. All this together, what we have been able to do is, this is the Chennai city, you can see this different color, and using the high resolution, the DM from Cartosat, these are the red are the buildings which are going to be submerged, more than 3 meter. The orange is 1 to 3 and yellow is 0 to 1. So you know ward-wise what kind of a flood situation, and accordingly the planning can be taken place. So such system is for Chennai, for Bombay also it has been functional now, and the other cities will be coming up soon. The next is weather and climate. One of the most important thing for India is a monsoon, because almost 50% of people depend on monsoon, and about 17% our income or GDP depends on how the monsoon is. So this is very critical, and the last few years, what has been able to do is the seasonal prediction model, then the extended range, and the short range predictions. All these 3 models have been now developed, and we have been able to give forecast. You must have seen that the forecast has improved drastically. Today, also the first seasonal prediction has been given. Now, this has a lot of implications on variety of sectors. It could be on agriculture, water, power. There are actually 30 different sectors which depends on the accurate forecast of this monsoon. I will give you only one example, that is for the agriculture. Now, once you have a good forecast, this is converted into what we call as agrometeorological advisories, which provides the information on rainfall, maximum, minimum temperature, cloud cover, humidity, and wind. And this allows the farmers to use this information for their agriculture practices, including plowing, sowing, irrigation scheduling, fertilizer, pesticide applications, crop selection, and many more things. And this is now functional. 93% farmers use this, and it is given in the local language. I mean, it's not that everything in English. It is there are several. Each district has a unit which provides this information, and the annual economic benefit, as calculated by National Council of Applied Economic Research, is 10,000 crores. So it's a huge benefit comes when your forecast is improved. Now, this is only one sector. There are several other sectors which get also benefit from this accurate forecast. Now, the monsoon, as I told you earlier, we are able, but what is likely to happen in future? So we also need to understand what happened in the past. And there was a major experiment. Drilling was done in Arabian Sea in Lakshmi Basin using an American ship called Joyous Resolution, and two boreholes about 1.2 kilometer deep were dug to understand what happened in last 40 million years. This was a very major experiment. There were 24 PIs, 12 from India and 12 from US. It was a real joint collaboration. But one of the very important came that our monsoon, what we call as a summer Asian monsoon, actually happened around 3.2 to 2.8 million years. Those who are geologists, of course, here are many. It's a mid-Pliocene period, and that time the temperature was more or less similar to as of today. Even carbon dioxide was about 400 ppm. So more or less same climate, and as the Himalaya rose, the monsoon became intensified, and actual current strength of the monsoon achieved around 1 million years ago. So this is very important information came out of this. There are many others. Till then, it was believed that the monsoon started around 8 million years ago. But this provided a very conclusive proof about this. So this is one area which is basically mostly geoscience have done this work. Now, this importance of this is that what is likely to happen in the future. And now the future projections, we know that it is likely to be decrease in light rain and increase in heavy precipitation. Many of us, you may be now experiencing last several years that when it rains very heavily, and the light and moderate events have reduced drastically. Now this is what is seen also in all different models, that light rain is going to decrease. Now it has a lot of implications. The one implication, very simple, is that the percolation will stop, most of the water will run away as a runoff, and groundwater would be depleted. So we need to make necessary engineering structures to preserve the moisture into the ground. So this is one. There are many other projections. I will show you a few more. But the advantage of knowing this well in advance is tremendous. Also, planning major infrastructures. You know, most infrastructure projects, they take about last 40 years or 50 years data to see that what should be the maximum and what they should plan. Even Delhi airport, they took 100 years data, past 100 years data to plan. And the first year itself, it got flooded because that kind of rain never occurred in last 100 years. So what we need is now what is likely to happen in next 100 years or 40 years or 50 years to plan large infrastructure projects. So this way, these models are extremely useful. Now you can see that most models now show that the rainfall is going to increase. There may be variation into numbers, but all models shows that the rainfall is going to increase. Now this is what is also possible, because if it's the heat increases, the more water vapor would be in the atmosphere, and naturally it has to come back. So more rains are expected in now, but they would be more on the extremes than the light and moderate. Now, the other changes which we have noticed is the rainy season has now changed, and what we are now seeing is northwest India, especially Rajasthan, Gujarat and parts of Haryana and all. The rainy days have increased, the rainfall has increased about 8%. Now you see regularly flood in Gujarat and Rajasthan, and even in Pakistan, which area never had floods earlier. So the rainfall, the other is that the rains are moving from east to west. Now, the other important thing in northwest is the Indus. The Indus River mainly depends on the snow and ice melt, not on the monsoon like Ganges and Brahmaputra. And the today our food production mainly because of Bakra, which is because of the Satluj, which is mainly fed by snow and ice. And we do not have much idea about the variability in the snowfall because those areas there are no measurements are done. And we need to understand that what is happening in the Indus Basin, whether rainfall is increasing or decreasing. If you see indirect evidences, most glaciers are receding. That means the snowfall also has reduced. But it has a lot of implication on the water in northwest India and Pakistan. So this is another area which needs a very careful investigation. Of course, this we have discussed. Now, there are other ocean. One of the important service like a farmer we are providing to fishermen is that where the fish would be available. It's a very intense process with the satellite-based ocean color data. The ocean color provides chlorophyll, that is an index of a food, and that sea surface temperature, which is taken as an index of an environment. Now, you know that both when the food and environment is conducing, the fauna likely to aggregate there, the fish likely to aggregate there, and this is what is a use in a very complex way this is being done. But this system allowed that success is about 80%. You can see these are the sites given for the fishing. The search time reduced to 60-70%. Now, this has a lot of implication. That much less carbon dioxide you are putting into atmosphere. It is computed now that 0.16 tons of carbon dioxide is less put by each trip any vessel makes. So it's a huge environmental benefit. But some can argue that when you increase in the catch, you are trying to overfish. Now, as you see, in last 25 years we have been giving, our catch has not increased. Our catch remains more or less around 3.8 million tons, while the potential is 5.31 million tons. So that means we are still fishing within the biological sustainable limits. But it has a lot of other advantage, and it has an economic benefit about 17,800 per trip. Now, if you want to sustain this, we also need to do some more modeling work. We know that the physical processes, this is in the sea surface temperature and the chlorophyll. You can see that when the temperature becomes cooler, the chlorophyll increases. So there is a connection between the physical and biological processes. Now, this we should be able to convert this primary productivity to tertiary and secondary and tertiary productivity, and whether we can build a fish stock models. That means we are now telling before harvest that this year we are going to get wheat 180 million tons. Now same thing whether we can say that this year we are going to get a fish stock of a sardine is going to be X million tons, and accordingly the fishing can be done. So the initial work has been started that how the physical and biological process, we can couple it with the models, physical models, so that we can give a short-term and annual fishery forecast. So this is a very important area to make a fishery as a sustainable. Now with this, when you want fishing, the coastal ecosystem, especially the mangroves, coral reef and seagrass, also has to be in a healthy condition, because these provide the breeding and spawning ground for the fishery. So we need also to have that understanding about structure, function and vulnerability of these systems so that we can understand. Now, why this is very important is there are several services which is provided by. Mostly we are aware that it provides the food, fish, fodder and fuel. This is practically known. But there are many other services. One is the regulating services. How the sediment transport moves, how the wave is attenuated, how the shoreline is protected from the waves and the other storm surges. That is not known. What is their role in primary and secondary production, in carbon sequestration? This is also not well understood. And of course, this is known that it helps in recreation, research and education. But these two surveys is not pretty well known. So there is a lot of scope for us to understand that what this services which is given, and the most important is what is their economic value. So this is an area which we need to find out, that this services, what is the economic value. Also the the coast, we know that because of the sea level rise and many other things, there is a large scale erosion. So we need to have a model by which we can say that which coast is vulnerable and what is the magnitude of that vulnerability. So this model has been developed which can tell you that, so this red is vulnerable, that means you may have to put large amount of money to secure this region. But this yellow are much safer area to do any other work. The polar sands is, we consider Himalaya, Arctic, Antarctica all as a polar sands. And the glaciers, of course, we know it's all reducing. The total area which is lost is about 16-17%. And the same is in the Himalaya, 16%. That means the amount of the accuracy of our data is quite good. Indian Himalayas and the Chinese Himalayas are retreating more or less in the same manner. The Karakoram, of course, is stable or advancing. This information about the entire Himalaya is very critical for us, because there is initially IPCC said that by 2035 all glaciers will be lost without any actual data. Now we have the data and we know that it is not going to be lost by 2050 or even not even after that. Now, but important thing is most of the work which is being done at this snout, this is the only work which is done all along and the entire Chadra basin. You can see that the measurements are done in all areas. So that means to calculate the change in the mass, because the area doesn't tell you how much mass is lost. What is important is how much mass is we are losing. So this is being done, and in Chinese side, the one data showed that we are losing about 4 billion tons of ice. Now this is a huge number. Now this is one, if it is true, such a large mass when converts from the land to water and ultimately to the sea, how this change in the mass is affecting what we call as the isostasy. The fracture which I showed in the Rishiganga, I'm not saying that this because of this, but this is an area where not much work has been done. That when you lose the mass, if one changes from one place to the other place, what exactly happens and how we can address this issue. Same thing is for the groundwater. We know in northwest Punjab, Haryana, that groundwater has gone drastically below. Where that water has gone, whether it is in atmosphere or whether it is moving ultimately through river to the ocean, this large-scale change in the mass is not understood. And I think this is an area where the university, I think, is the best place to understand that what is happening when such change of mass is occurring. Now, India is now very active in the Arctic. Now, why India should be very active in the Arctic? The most important thing which we learned, that cold episodes in North Atlantic, in Arctic, has a very good connection of weakening of monsoon in India. That means when there is a cold episode, the monsoon will be affected here. So there is a teleconnection between what happens in Arctic and Indian monsoon. So this is very important for us to understand that, and that is why we have a major presence in the Arctic. There is also a study done, and through INSAT it was found, when there is a huge rainfall, what happened in Kashmir and Pakistan, the transfer of latent heat from here to goes right up to the Canadian Arctic, and the melting increases there. So there is a cause and feedback continuously happening. So we have a now station in Arctic, we have station in the Canada also, and we are planning to have station in Greenland and Alaska, so that we understand what is happening there, which has a very much influence on the India. Apart from that, we also need the satellite receiving stations so that we get a real-time data from the entire globe. We have one in the Antarctica where we are getting 9 to 10 orbits, and one we have in North, and the entire globe real-time data can come to us. There is also a lot of oil and gas in Arctic, and the critical metals. As we go to renewables, the requirement of a cobalt and nickel, apart from lithium and the other rare elements, is pretty high. The one estimate the global demand, if we go to the renewable, the demand of nickel will be 500,000 tons and the cobalt 200,000 tons annually if we really want to do a renewable. So it's a huge, from where we are going to get these metals. And that is why India has invested very heavily into the deep ocean, where we are trying to find, and there are already manganese, cobalt, nickel, and we are trying to find out how we can retrieve them. Also the newer shipping routes and seabed survey. So there are a lot of new challenges which are coming up for us to go and study in the Arctic. And same thing in the Antarctic. The India was attached to Antarctica about 180 million years ago. So, and then it separated. Current our station, this Bharti, is in place where the East India and the Antarctica was joined. So how this fragmentation occurred is one problem which is yet to be resolved. So the detailed mapping and understanding on the Antarctica side has been initiated. We know mostly on the East Indian coast, but on the Antarctica coast. There is another reason for doing all this. You know, you know that these huge minerals you get in Australia and South Africa. All were attached at the same time. Why we are not getting similar thing in India? So this is an answer which we need to give. Also, similarly Arctic, Antarctica also affects our weather and climate. There are a lot of paleoclimatic study done which shows that there is a connection between Antarctica and India. Also the biodiversity and potential discovery of drugs, because all fauna and flora there survive in very extreme conditions, -90, and the blizzards are 200 kilometers, snow blizzards, so very extreme condition. So this is also potential area. So this we can do only if you are there. India has currently 2 stations which are manned round the year, and there is in the future there will be much more stations will be coming up. Now, what I talk mostly is about the knowledge of generating the Earth system. But this knowledge is not sufficient unless you have a suitable social system. That means governance, policy, and infrastructure. I give you one example. We all know now that the climate change is reality. There was a Paris Agreement. All countries have agreed that we should keep it up to 1.5 or up to 2 degrees. But when in US it changed, President Trump walked out of the Paris Treaty. So if this system is not available, suitable to this knowledge is not of any use. Also, you need sufficient infrastructure to use this knowledge. So you, along with the knowledge, you need a governance system, appropriate policy, and necessary infrastructure. Even if you have these two, the behavior of a human system, the human itself, is also very critical. One example which I give you is saving of energy. If you see today in India and US, if you compare, they use 22 times more energy than in average Indian. Now, whether it is really required, the argument is that we are able to afford so we can use it. But at whose cost? Somebody is paying for it. So that realization of individual that I need to save energy. Most Indian homes I have seen, they switch off the light when they went out from one room to other room. You will never see this is happening in US. So even if you are able to afford it, the question is not that, whether you need it. If you need it, you use it. But if you, just because you are able to afford the wastage of food, energy, anything, depends on the human system. And that is why all these three has to come. Otherwise, our activities and the impacts are known. And that what we will, all has to suffer. Even if one country or few countries doesn't believe, the suffer will be done by everybody. So with this, thank you very much for this opportunity.
After such insightful talk, the session is open to the questions. Couple of questions can be taken.
They're a little bit shy, so don't want to ask. But it doesn't matter. Your question, whether it is, you don't have to worry whether it is a right question or a wrong question. Question is always right. Don't have to worry. Okay, then. Thank you. Thank you.
So if there are... So I now request Dr. Aliva for the vote of thanks.
As we bring the gardens down on this remarkable Golden Jubilee IOE Distinguished Lecture, it is my distinct honor and privilege to extend a heartfelt thanks on behalf of the Center for Earth, Ocean and Atmospheric Sciences to all those who have made this event a successful one. Our sincere thanks goes to our speaker, Padma Shri Dr. Shailesh Nayak, for first of all accepting our invitation to be here with us and deliver your talk despite your other commitments and your busy schedule. Your brilliant talk on benefits of Earth system science in India, covering the entire spectrum of Earth sciences from cyclone to tsunamis to earthquakes to monsoon to fishery to polar sciences, has inspired us, has benefited us, and I'm sure that it has been an eye-opening for the students present here. So we look forward to having you in our midst even in the days to come. And we thank you once again for your wonderful speech. We also thank our respected Vice Chancellor, Professor Vijay Rao, for gracing this occasion and addressing this August gathering with an emphasis that there is a need to look at Earth as one unit and not as separate entities. We are deeply honored by your presence and for your support and for being with us throughout the program despite your heavy schedule and other commitments and programs. Thank you, sir. We are also thankful to our IOE director, Professor Ghanshyam Krishna, for always supporting us throughout this, through this kind of events and for sponsoring this talk as well. Thank you, sir. A heartfelt gratitude also to our Professor James Raju, our Dean, School of Physics, who could not be here due to some other commitments. And also to our head, Professor Jayananda, for gracing us with your presence and especially for your continuous support and guidance in making this event successful, and also for leading with example towards achieving academic excellence for our school and our center in particular. Thank you, sir. To the organizing committee, senior faculty members, fellow faculty members, our PhD scholars, our dear students, administration staff, volunteers who have been working tirelessly behind the scenes, your dedication and hard work have made this event a successful and a memorable one. Thank you. And we also thank our media persons who are here and who will take this event to even wider audience. We thank you. And we also would like to thank our convener, Dr. G. Gishore, for again working tirelessly and in his efforts in making this event successful, and for letting us see the light of this day for this event. Thank you. In conclusion, let me express my profound gratitude to all our distinguished scientists and our guests from other institutes and even from other schools of the university. We thank you for gracing us, and because of your presence, this event has been a successful one. We thank you, and we thank you one and all. Thanks. Sorry, there's an announcement. There will be a group photo just outside the center, so please gather there for a photo.
They will come and they will wider.